All right, get ready because we're about to go deep, really deep into some ancient astronomy.
Oh, yeah, this one is a doozy.
A theory that's going to leave you looking up at the sky and wondering what our ancestors really saw. We're talking about the Saturn myth.
This is gonna be good. It's not just about rings and moons.
We're talking about a whole different way of seeing the universe.
Where Saturn was the big cheese, not our sun.
Yeah, you heard that right?
Mhm.
The ancients saw Saturn as the dominant force in the sky.
So buckle up. This is gonna be a wild ride.
Oh, and before we get started, hit that like button and subscribe so you don't miss out on future deep dives. You, our listener, are the kind of person who wants to go beyond just like the surface level. You want to really understand how things fit together. And we've got some seriously fascinating pieces for you today. We're going to explore something really wild. The possibility that the history of our solar system, the place where we all come from, could be drastically different from what we've always been told.
Yeah, think of it like we're doing cosmic archaeology. Sifting through ancient myths, astronomical observations from civilizations that have been gone for centuries, geological puzzles right here on Earth, and we'll even look at some of the newest discoveries about how other star systems work. It might sound like a random mix, but trust me, we're on a quest to see if all these clues point to a single mind-blowing narrative about our deep past.
Mind-blowing is an understatement. We're not just talking about minor tweaks to the story here. We're going to dive headfirst into the idea that our solar system had a completely different structure, a different way of working altogether. And this has implications for everything from how the dinosaurs died off to the climate that our ancient ancestors lived in. Get ready, because this deep dive is going to take us on a journey through time and space that might just make you question everything you thought you knew. All right, let's jump right in. Stick with me here, it's all connected. We're going to talk about how much ancient civilizations actually knew about astronomy. And we'll start in Mesoamerica with the Maya.
The Maya, they were around for centuries in Central America, and they had this unbelievable understanding of math and astronomy. Their calendars were super intricate, able to track huge spans of time, and they could predict eclipses, both solar and lunar, with amazing accuracy. But one of their most incredible achievements has to be how well they understood the Venus cycle.
Yeah, the Venus cycle, that's the time it takes for Venus to get back to the same spot in the sky relative to the sun. And the Maya tracked it really precisely in their codices, especially the Dresden Codex, am I right?
You got it. The Dresden Codex says that Venus takes 11,960 days to complete 405 lunar cycles. Now, with our modern calculations, we know the real number is 11,959.89 days. The Maya were only off by 1 day every 380 years. Think about that. They got that level of accuracy without any of the fancy tools we have today. It just makes you wonder, what else did they figure out about the universe that we haven't rediscovered yet?
Seriously impressive stuff. Makes you wonder what other secrets are hidden in those ancient records. Okay, let's head over to the ancient Babylon, another place known for its astronomical knowledge.
Babylonian astronomy is just as amazing, and it goes back thousands of years. They kept these super detailed astronomical diaries written on cuneiform tablets. Those are clay tablets with wedge-shaped markings, and they recorded all sorts of celestial events with crazy accuracy. These records span centuries, so we have this amazing long-term view of how the stars and planets were moving.
So they weren't just casually looking up at the sky. It sounds like they had a whole system for studying the heavens.
You're exactly right. The stuff they wrote in their diaries is so accurate that it lines up perfectly with the predictions made by the Hellenistic astronomers way later in ancient Greece. That tells us there was a long tradition in Mesopotamia of carefully watching and recording what was happening in the sky.
All right, so we've got these two ancient cultures, miles apart and with totally different ways of life, both with this deep understanding of how things move in the cosmos. And now, this is where things get really interesting and start to tie back to our initial idea of a different solar system way back when. Our sources highlight this super intriguing idea, a much closer connection, maybe even a complete overlap between Saturn and the Sun in ancient beliefs.
This is where things start to get really unconventional. Think about the Sanskrit name for Saturn. It's Sara. And get this, Sara also means solar day and solar month. That's not a coincidence. It's just a strong link, maybe even an original identity, between Saturn and the sun in ancient Hindu beliefs.
Wow, that's more than just a linguistic connection. It's like they saw Saturn as something more than just a planet. It was tied to the concept of solar energy and time itself.
Exactly. To the ancient Hindus, Saturn and the sun may have been seen as almost the same thing, interchangeable in certain situations, and there's more evidence for this. Let's look at some astrological reports from Assyria and Babylon.
Ooh, cuneiform tablets filled with astrological omens. This sounds juicy. What do they tell us about Saturn and the Sun?
In a lot of these reports from Nineveh and Babylon, you find this phrase, "When Shamash stands in the halo of sin, such and such will happen." Now, scholars have always said that Shamash and Sin were the Babylonian gods for the sun and moon, respectively. So the usual translation is, when the sun stands in the halo of the moon, which makes sense with what we know about their gods and astrology. But here's the twist.
Okay, I'm on the edge of my seat. What's the twist?
Some of those cuneiform tablets have a gloss, basically a little note that explains or clarifies something. And this gloss says that Shamash, in this specific context, isn't the sun, but the planet Saturn. The Babylonians also called Saturn Lubat Sagius.
Wait a minute, so when they were talking about this particular alignment, Shamash actually meant Saturn. That changes everything.
Right. And this isn't just a random occurrence. When we look at Semitic languages, the word for sun comes from the name Shamash. Hebrew has Shemesh, Aramaic has Sames or Simsa, Arabic has Samsu, even Maltese has Zemex. But that little note, Samseumi, meaning Samas of the day, seems to have been added later. Maybe to clarify, maybe even to correct an older understanding where Shamash primarily referred to Saturn. It seems like over time the meaning of the name shifted, but there's still a trace of that old connection to Saturn.
So maybe the name Shamash originally meant Saturn, but then, I don't know, maybe their understanding changed, maybe Saturn itself looked different and the name got attached to the actual sun. It's like finding a fossil trail, but for language. It's like they're all pointing back to Saturn as something really important in their cosmology.
Right. And Donald Mackenzie, a scholar of ancient myths, wrote that the sun god was the same as Ninip and Ningirsu, and was like Babar, the shining one, the sun god, whose Semitic name was Shamash. They're all connected. And here's something even more convincing. There's a carved image of Ninurta on a slab from his temple in Kalak. And in this image, he's holding a scythe, which is the same tool associated with the Greek god Kronos. And Kronos is the Roman equivalent of Saturn.
Yeah, a scythe is a pretty specific symbol. It's hard to ignore that kind of visual link.
Totally. Plus, Franz Kugler, who studied Assyria, and Morris Jastrow, a religious historian, both said that the planet Ninib, also known as Ninurta, was the same as Saturn. They based this on all the texts and images they'd studied.
Okay, so there's a lot of evidence, linguistic and visual, that in Mesopotamia, Saturn was linked to the sun, maybe even originally seen as the same thing. Now let's go back to India and talk about Surya, the Sanskrit name for the sun.
Some ancient texts describe Surya in ways that don't match what we know about the sun now. For instance, they say Surya stays in Samanamdama, which means the same place of rising and setting.
That's not our sun. The sun rises in the east, sets in the west, and its position changes throughout the year because of Earth's orbit and tilt.
Exactly. If we're thinking about Saturn, though, maybe in a different configuration, maybe where its movement wasn't so noticeable, this description makes more sense. The important thing to remember here is that this idea that Saturn was once something more than just a planet isn't just coming from myths and symbolism. It's coming from what seem to be actual ancient astronomical observations and claims.
So it's not like they were making up stories. They were trying to describe what they saw, what they knew about the universe.
Yeah.
Even if their understanding was different from ours.
Right. Now, this brings us to a big question raised by Morris Jastrow back in 1910. He was trying to figure out how those ancient people could possibly seen Saturn, which is just a faint dot in the sky, as a sun. It does seem pretty impossible from our perspective.
It does. Even with a telescope, Saturn isn't exactly a blazing star. It's beautiful with its rings, but it's just reflecting sunlight.
You got it. Jastrow, looking at it from a 20th century viewpoint, couldn't understand how those ancient claims could possibly be true. But the main argument against him is that maybe the ancients saw something totally different, or even crazier. Maybe Saturn itself was different back then. Maybe in some way it actually was a sun.
Okay, that is a huge idea to wrap our heads around. Saturn is a sun. How could that even work? To figure that out, we've got to talk about how planets move and how our understanding of the solar system and other star systems has been changing, right?
Exactly. Our usual ideas about how solar systems form and stay stable have been challenged by the discovery of exoplanets. Those are planets orbiting other stars. And even here in our own solar system, there have been mysteries, like Avenden's principle of least interaction action. This principle tried to predict how planets would orbit in a stable way, suggesting they had arranged themselves to minimize gravitational interactions. But when Ovenden tried to apply his principle to our solar system, it didn't quite work. It couldn't explain the orbits of Jupiter, Saturn, Uranus, and Neptune.
So the math didn't match what we actually see in our solar system.
Not unless he made a big and controversial change. To make his principle work, Ovenden had to say there was once another massive planet, maybe even bigger than Jupiter, that somehow got kicked out of our solar system. And he thought this happened relatively recently, like 16 million years ago. He also suggested our solar system might still be adjusting to this lost planet, slowly settling into a more stable arrangement.
That's a pretty dramatic idea. A whole other giant planet that just got flung out into space, leaving the rest of the planets to figure out their new orbits. And this wasn't that long ago in cosmic terms. It really shows how much solar systems can change over time.
You're right. And then there's all this new information about exoplanets. These planets orbiting other stars are showing us a crazy variety of solar systems, many that are nothing like ours. We're finding gas giants, sometimes way bigger than Jupiter, orbiting super close to their stars. And some have really weird orbits, not nice and circular like most of the planets in our solar system.
So our idea of a star with planets orbiting neatly around it seems to be pretty unusual.
That's what it looks like. The astrophysicist Fred Razio even said, "You get the impression that most solar systems are not like ours." For example, there's a planet around a star called Taubutis, which is a bit bigger and hotter than our sun. And this planet is almost 4 times the mass of Jupiter, but it orbits its star in just 3.3 days. That's closer than Mercury is to our sun.
That's incredibly fast. It really shows that there are all sorts of weird arrangements out there. What about rocky planets like Earth? Does all this tell us anything about how they form?
Actually, how Earth and planets like it form is a bit of a mystery. As someone said, we may never know exactly how the Earth and its sister planets were born. By the late 1990s, the main theory, called core accretion, the idea that dust clumps together to form bigger and bigger objects, was having trouble explaining some things, especially how gas giants form. And another model, called the accretion disk model, which says planets form within a swirling disk around a young star, also has some problems.
So what we thought we knew about how planets form isn't the whole story.
Not quite. Even Uranus and Neptune, the ice giants in our outer solar system, are hard to explain with our current models. Joshua Roth, a planetary scientist, even said, "Pity Uranus and Neptune. No one can even explain why they exist." It just goes to show that we're still figuring out how planets form and how solar systems change. Our solar system, with its relatively ordered arrangement, might be more of an exception than the rule.
This uncertainty about planet formation and the fact that solar systems can be so dynamic definitely makes it easier to consider some more radical ideas about our own past. And one of the most interesting ones is this hypothesis that proto-Saturn, which is what they call it in these alternative theories, might have actually been a brown dwarf star early on. For people who don't know, what exactly is a brown dwarf?
You can think of a brown dwarf as a star that didn't quite make it. It forms like a star from a collapsing cloud of gas and dust. But it's not massive enough to start and maintain nuclear fusion in its core, which is what makes stars shine like our sun. Brown dwarfs do give off some heat and light, but they're much cooler and dimmer than regular stars.
So picture this. Our early solar system, but instead of just our sun, there's this other dimmer object, proto-Saturn, the brown dwarf. And the theory says that around proto-Saturn there was this big cloud of stuff, maybe a circumstellar disk, kind of like what some ancient cultures called chaos. It might have even looked like a swirling ocean in the sky to them.
That's a key part of this theory, and it leads to an even more mind-blowing question. What if Earth wasn't always going around our sun? What if, for a long time, it orbited this proto-Saturn brown dwarf, much farther out in space where it's much colder?
That goes against everything we think we know about life. Don't we need a star like our sun for liquid water and life to exist? How could Earth be habitable way out there with a dim brown dwarf?
I think we're so used to our own sun that we assume that's the only way for life to exist. But scientists are starting to get really interested in dwarf stars, especially red dwarfs, as places where there might be alien life. They're smaller and cooler than our sun, but they are still stars. And Ken Croswell, an astrobiologist, said, "Far from being desolate backwaters, red dwarfs may harbor an abundance of alien life." Red dwarfs live a really long time, so they could provide stable conditions for billions of years.
Yeah, I remember hearing that. But brown dwarfs are even dimmer than red dwarfs, right? Wouldn't it be even harder for a planet to be warm enough for liquid water around one of those?
That's usually true. If a brown dwarf is out there all alone, it wouldn't give off much warmth or light. But this theory about proto-Saturn is different. It says that Earth, orbiting a young brown dwarf that was still relatively warm and maybe more active, could have gotten enough energy to support life. Plus, we have to remember that there might be other ways for photosynthesis to happen, not just the way it works with our sun. The big question is, was the sun that warmed early Earth our current sun? Or was it something else? When we look at ancient climates, the answer might surprise you.
You're talking about how there weren't really distinct climate zones a long time ago,
Wow.
about how there was tropical stuff at the poles. Can you tell us more about that?
Absolutely. When we examine the geological record, specifically during the Quaternary period, which includes the ice ages, and even further back, like the Carboniferous period, we don't see the clear climate belts that we have on Earth now. The evidence points towards a more uniform climate across the globe. And there's another interesting thing. Paleobotanists have found fossils of tropical plants and animals in the polar regions, but the rest of the planet wasn't necessarily that much warmer. This really challenges our idea that the sun is the only thing controlling Earth's climate. The paleoclimatologist Barbara Bell even asked, how could the sun have been strong enough to make the poles so warm without making the tropics too hot for anything to live?
That's a really good point. If our sun was the only source of heat, it's hard to imagine how those polar regions could have been warm without the tropics being like a furnace. It makes you think there might have been another heat source back then.
This also brings up the idea of polar wandering, which is the idea that Earth's magnetic poles, and therefore its rotational axis, have moved over time. The geophysicist Don Anderson said that these changes in Earth's orientation could have caused the continents to split apart. He suggested that rapid shifts in Earth's axis could have triggered things like continental rifting and the formation of subduction zones.
So big changes in how the planet was tilted could have caused a lot of geological upheaval. And this brings us back to the theory that Earth was initially orbiting proto-Saturn in a different way, maybe around its equator.
Yes. People like David Talbot and Wallace Thornhill, who support this model, have said that Earth might have started out orbiting proto-Saturn closer in and around its equator. Then, when the proto-Saturn system got closer to the sun's influence, this arrangement might have gotten stretched out and reoriented. They think Earth and Saturn might have lined up along the same axis relative to the sun. But they also think this was just a temporary phase. Eventually, it broke down because of gravitational instability, kind of like how Jupiter's gravity ripped apart that Shoemaker-Levy 9 comet.
So it's like a cosmic dance with the planets changing partners as they moved into a new gravitational environment. How would Earth have gotten light and heat in this proto-Saturnian system?
The theory says that proto-Saturn, even though it was a dim brown dwarf, would have a large plasmasphere. That's a big region of charged particles around it. It's similar to Jupiter's huge magnetosphere or the sun's heliosphere, and this plasmasphere, they think, could have acted like a mirror, reflecting proto-Saturn's dim light and heat towards Earth. So no matter how Earth was tilted or where it was in its orbit around proto-Saturn, it would have gotten some warmth and light.
It's like a giant cosmic lamp, dimly lighting both proto-Saturn and Earth. And that could explain how ancient climates were more uniform and how the poles were warm without the tropics getting ridiculously hot.
Exactly. This scenario could have created a kind of perpetual twilight or a really long sunrise, not super bright, but still warm. Maybe that's what some ancient cultures were remembering when they talked about the dawn of creation, the time before the sun's light and heat became dominant on Earth. It's also theorized that both Earth and proto-Saturn were inside this big plasmasphere, and that helped to spread the radiation more evenly.
So Earth was getting enough heat from being close to proto-Saturn, especially in the north, and then getting some extra warmth from this plasmasphere reflecting heat towards the south. What kind of climate would that create?
It would be a climate with almost no seasons, like a permanent spring, and the temperature differences between different latitudes would be pretty small. This could explain how tropical plants and animals could have lived so far north, even in what's now the Arctic. Maybe they even originated there. And the fossils that we find in those regions, from maybe as far back as the Cretaceous period and definitely from the Paleocene epoch, seem to back this up. This whole idea of Earth being a satellite of proto-Saturn suggests that we might need to rethink everything we thought we knew about Earth's history before the Pleistocene, including how life began and evolved.
This is mind-blowing stuff. It's making us question not just how the solar system works, but also the entire history of life on Earth. Now let's talk about this idea of a stationary Saturn, especially the idea that it was once located at North Celestial Pole.
You know, it's fascinating. In cultures all over the world, from Mesopotamia to Egypt to the Arctic, There are stories and astronomical traditions that say Saturn used to be in a special place in the sky, often fixed and unmoving, and often associated with the North Celestial Pole, the point that all the stars seem to rotate around.
But as we discussed earlier, some people say that these are just symbolic, metaphorical figures of speech that were used in ancient astrology. What's the argument against that?
Well, our source asks a good question. If these were just symbolic, why did they use those specific symbols for Saturn? Why was Saturn, out of all the planets, the one that they associated with stability, stillness, and the North Celestial Pole? The source points to the idea of a stable or resting Saturn that was common in ancient Semitic traditions. In Hebrew, Saturn is called Shabtai, and in Akkadian, it's Satum. Both of these names have to do with the idea of resting. And Chian, the Assyrian and Babylonian name for a deity associated with Saturn, comes from words that mean to establish, fixed, firm, stable. These names themselves suggest that they saw Saturn as a planet that didn't move.
The resting planet. It's hard to believe that they came up with that idea purely out of symbolism. It seems like they must have actually observed something.
Exactly. The source also mentions the god Hamu, who's been considered a sun god for a long time. He's closely associated with the Babylonian king Hammurabi. But since we were talking about how Shamash, another god connected to justice, might have originally been Saturn, maybe Hamu was also an early name for Saturn.
So even gods that we think of as sun gods might have been connected to Saturn in the past. What about Osiris in Egyptian mythology?
Osiris was definitely seen as the god of the north in ancient Egypt. Some people, like E.A. Wallace Budge, interpret this geographically, but our source suggests that they were talking about the sky. They believed Osiris lived in Sekbet Hetepet, among the imperishable stars, which are the stars that never set below the horizon and that you can always see in the north. They also believed that when pharaohs died, and eventually all good souls, they'd join Osiris in this northern part of heaven.
Again, this reinforces the idea that in ancient times, there was something important and powerful in the North Celestial Pole. And then there are those stories about a time of darkness before creation in places like Polynesia and Australia.
Yes. The Neurons of Polynesia have stories that describe complete darkness at the very beginning of the universe. And the Aranda people in Central Australia tell a similar story about a time when everything was in darkness before the world was created. The source suggests that maybe these widespread memories of primordial darkness are referring to a time when Saturn was the only light source. Maybe it was at the North Celestial Pole and it gave off just a faint light. It was a kind of twilight or a very slow sunrise that they later remembered as the first light, the beginning of creation.
So in the early universe, maybe there was a dim light, probably located at the North Celestial Pole. Ancient cultures remembered this as the first light after a long period of darkness. This paints a very different picture of the early universe than what we're used to. Now let's talk about the habitable zone. The area around a star where conditions are just right for life.
Right, the habitable zone or the Goldilocks zone. It's the area around a star where a planet could have liquid water on its surface. And we think liquid water is essential for life. Earth is in a good spot in our solar system's habitable zone. That's why we have oceans and life.
Too close to the sun and the water boils away. Too far and it's just ice. Earth seems to be in a perfect spot.
Exactly. But the model we've been talking about suggests that Earth might have been habitable even when it was orbiting a brown dwarf star, proto-Saturn, way out in the cold depths of space. We talked about how proto-Saturn's plasmasphere might have been able to spread enough heat to Earth. And here's more evidence that supports the idea of a different, more uniform climate in the past. During the Carboniferous period, there were huge coal swamps with tons of fossilized trees. And these trees didn't have growth rings.
No growth rings. That's strange. Trees usually have those rings that show how much they grew each year.
I know, right? Also, Berghorn, a paleobotanist, said it's really hard to explain why those Carboniferous trees didn't have those rings unless we assume there weren't big temperature changes between winter and summer, and that the rainfall was pretty consistent over large areas. Now, some modern plants that live in places where the climate doesn't change much might have faint or irregular growth rings. But usually, trees that experience seasons have very clear annual rings.
So it seems like something was different back then.
It does. And to make things even more intriguing, remember how some ancient texts described a time when people didn't live in houses? The Sumerians, for example, had stories about ancient days when people didn't know about tents of habitation. Maybe this suggests that the climate back then was so mild and stable that they didn't need shelter the way we do now.
Okay, so maybe our ancestors lived in a world with a very different climate, one that was more even and pleasant across the globe. And that brings us back to brown dwarfs. We talked about them being failed stars, but they're still fascinating objects, right?
They are. Brown dwarfs actually give off more heat than they receive from their surroundings. It's kind of like Jupiter and Saturn in our solar system. They radiate more energy than they get from the sun. A scientist named Philippe André Martin has said that studying isolated objects that are about the same mass as planets can help us understand what Jupiter and Saturn were like when they were young. He thinks that sub-brown dwarfs, as they cool down, might actually turn into giant gas planets, what we could call protoplanets.
So the idea is that Saturn, back when it was a brown dwarf, was like a protoplanet that eventually cooled down and became the gas giant we see today.
That's the idea. And remember those plasmaspheres we were talking about? Planets and stars, even our sun, have them. Jupiter's magnetosphere, for example, is a giant bubble of charged particles that's 20 times larger than the sun. And that donut-shaped ring of plasma around Saturn, that could be a leftover from when it had a much larger plasmasphere back when it was proto-Saturn.
So if we could travel back in time and look up at the sky instead of our blazing sun, we'd see this dimly glowing reddish Saturn just hanging there. It's almost hard to imagine.
It really is. And here's where it gets even wilder. Imagine this massive disk of gas and dust, what Cardona calls a placental cloud, enveloping Saturn.
A placental cloud. That sounds like something straight out of like science fiction.
It kind of does, right. But, the truth is often stranger than fiction. Think of it as this cosmic whirlpool, a chaotic sea of matter swirling around Saturn. And Cardona suggests that ancient people might have perceived this cloud as a celestial ocean or a primordial void.
Okay.
And this concept appears in various creation myths around the world.
All right, so we've got this dimly glowing Saturn, this placental cloud, and ancient cultures seem to be fixated on Saturn as this primary celestial object. Is there any evidence to support this theory? I mean, beyond just interpretations of ancient texts and symbols?
Right. That's where things get really interesting.
Yeah.
Because Cardona doesn't just rely on interpretations of ancient accounts. He delves into mythology, geology, even astrophysics to build his case.
Okay.
But before we jump into that, I want to ask you, can you imagine the psychological impact of living under a sky dominated by a dim, immobile Saturn and this swirling cloud of cosmic dust?
It would be a completely different experience.
Right.
Our concept of day and night, of seasons, even of time itself would be completely different.
Completely different. And it's no wonder that ancient myths are filled with tales of a lost golden age, a time of primordial unity before the world as we know it came into being.
Okay, so where does the real evidence lie for the Saturn myth?
Well, one of the most striking pieces of evidence comes from those widespread myths of a golden age, this time of peace, abundance, and a different sky. And this resonates really strongly with the idea of a Saturn-dominated system.
Okay.
Where the sky would have looked drastically different from what we see today.
So instead of our sun and moon kind of doing this celestial dance, they might have experienced this dim, unchanging sky with Saturn at the center, this unwavering presence.
Precisely. And then there are these recurring myths of a celestial ocean or a cosmic whirlpool above the Earth. This upper water motif.
Right.
It's found in cultures all over the world, from ancient Egypt to the Norse Eddas.
Could this be a memory of that placental cloud surrounding Saturn? This vast sea of gas and dust that they perceived as an ocean?
That's exactly what Cardona suggests. And it's not just the visual aspect either.
Yeah.
These myths often describe the celestial ocean as a source of chaos and destruction, potentially hinting at the volatile nature of that Saturnian system.
It's like we're piecing together a cosmic jigsaw puzzle, connecting ancient myths with this completely new understanding of our solar system's past. But is there any scientific basis for this? For this wild theory?
That's the million-dollar question.
Yeah.
And it's really where Cardona's work gets interesting.
Okay.
Because he doesn't just dismiss mainstream science. He actually engages with it, using recent discoveries in astrophysics to support his claims. For instance, the very concept of brown dwarf stars. Those were unknown until relatively recently. So
the foundation of this theory rests on scientific discoveries that wouldn't have been possible even a few decades ago.
Exactly. And it goes beyond just the existence of brown dwarfs. Scientists have observed them, and they've seen them exhibiting some pretty surprising behavior, like emitting these powerful flares that dwarf anything our sun can produce.
Like these dimly glowing objects can unleash these massive bursts of energy.
Oh, absolutely. And remember, those are observations of brown dwarfs that are much smaller than what proto-Saturn would have been. So imagine the kind of energy a sub-brown dwarf like proto-Saturn might have been capable of releasing.
So it's not just some hypothetical idea.
Right.
There's actual evidence suggesting that a sub-brown dwarf like proto-Saturn could have been this really powerful dynamic force
Oh, yeah.
in our solar system.
And those powerful forces might have played a crucial role in shaping the Earth as we know it,
Right.
as well as the myths and legends that have been passed down for generations.
Okay.
But we're just scratching the surface here.
Yeah.
There's so much more to explore, from the potential geological evidence to the possibility that Earth's capture by the sun was this violent, catastrophic event. It's really mind-blowing stuff.
Yeah, this is shaping up to be one of our most mind-bending deep dives yet. Listeners, if you're anything like me, your mind is already swirling with questions and possibilities. We'll be back after a short break to continue this journey into the heart of the Saturn myth. Don't go anywhere. Okay, we're back. And I'm still thinking about these Saturnian flares, these cosmic upheavals, this totally different solar system. But before the break, you mentioned the electric universe theory.
Right.
What role does that play in all of this?
Well, the electric universe theory basically proposes that electromagnetism plays a much bigger role in the cosmos than we traditionally think.
Okay.
So it suggests that gravity isn't the only force shaping the universe, that there are these electrical currents, these plasma discharges that might be responsible for some of the phenomena that we see in space.
So instead of planets and stars just kind of, moving around due to gravity, we're talking about like a universe that's crackling with electricity.
Yeah, exactly. And that's where it gets really interesting in relation to the Saturn myth.
Okay.
So Cardona suggests that the transition from the Saturnian system to our current solar system might have been triggered by this massive electrical event, like a cosmic discharge of unimaginable power.
Okay, now that sounds truly epic.
Right.
But what kind of evidence is there to back that up?
Well, Cardona points to a number of ancient myths that describe the sky being ablaze with fire, gods hurling thunderbolts, and even the separation of the heavens and the earth. And he argues that these myths might actually be describing, albeit in symbolic language, the dramatic electrical events that accompanied the disintegration of the Saturnian system.
So these ancient myths might not just be like fanciful tales. They might be like echoes of real events that our ancestors actually witnessed.
Exactly. And it's not just mythology. Cardona draws upon certain geological features, like the scarring and vitrification of rock formations, as potential evidence of powerful electrical discharges in the distant past.
Vitrification. So you mean like rock being melted and fused together by intense heat?
Precisely. And the scale of some of these formations suggests, an energy source that's far more powerful than anything we typically associate with volcanic activity or other earthly phenomena.
So he's suggesting that these geological anomalies might be like the fingerprints of these cosmic lightning bolts.
Right. It's a bold claim, for sure.
Yeah.
And one that really challenges conventional geological explanations. But it's those bold claims that make the Saturn myth so captivating. It forces us to question our assumptions about the past and consider alternative interpretations of the evidence.
It's like we're looking at the world through a new lens.
Right.
Seeing familiar things in a completely different light.
Yeah.
But let's shift gears for a moment. If the Saturn myth is true, what are the implications for our understanding of human history and civilization?
Well, that's a question that really goes to the heart of what it means to be human.
Yeah.
Imagine a civilization living under the watchful gaze of Saturn. A world where the sky was this constant reminder of the power and mystery of the cosmos. The psychological impact of that kind of existence would been profound.
It's almost impossible for us, with our modern sun-centered worldview to even begin to grasp what that might have been like.
Right. And Cardona argues that this Saturnian influence might be reflected in ancient art, architecture, even social structures. The prevalence of megalithic structures like Stonehenge and the pyramids might be linked to an attempt to understand and perhaps even control these cosmic forces that shape their world.
So instead of just, tombs or temples, these structures might have been astronomical observatories.
Right.
Devices for tracking the movements of Saturn and the other celestial bodies.
That's one of the possibilities that he explores.
Wow.
And it adds a whole new layer of meaning to these ancient monuments.
This is mind-blowing stuff. It's like we're uncovering this hidden chapter in human history. A chapter that challenges everything we thought we knew about our origins and our connection to the cosmos.
And it's a chapter that's still being written.
Yeah.
The Saturn myth is a work in progress. It's an ongoing investigation, that requires further research and open-minded exploration.
Okay.
It's not about definitively proving or disproving the theory.
Yeah.
It's about, expanding the boundaries of our knowledge and challenging us to see the universe and our place within it in a new and perhaps even awe-inspiring light.
Well said. It's like we've been given this key to this vast, this uncharted territory. A territory filled with wonders and mysteries, just waiting to be discovered.
Right.
And while the Saturn myth might not hold all the answers,
yeah,
it certainly raises some fascinating questions.
Yeah, it does.
And challenges us to think beyond, the confines of our conventional understanding.
Absolutely.
Of the cosmos.
Yeah.
And our own past.
In our own past.
Yeah.
Before the break, we were talking about how recent scientific discoveries about brown dwarf stars actually lend some credibility to Cardona's claims.
Yeah, it's like science is catching up to these ancient myths.
It really is a fascinating convergence. And speaking of science, one of the most compelling aspects of Cardona's work is that he doesn't shy away from addressing the big thorny questions. For instance, how could Earth, orbiting a sub-brown dwarf like proto-Saturn, possibly have been habitable?
Yeah.
Wouldn't it have been, a frozen wasteland?
Right, because we're so used to thinking of the sun as this primary source of heat and energy, for life on Earth.
Exactly. But Cardona throws a curveball by suggesting that those powerful flares, the ones we talked about earlier,
right,
that are emitted by brown dwarfs could have played a crucial role in warming the Earth during that Saturnian era.
So instead of like a constant steady stream of sunlight, we're talking about these intermittent but incredibly intense bursts of energy.
Precisely. And those bursts could have had a profound impact on Earth's climate and environment. In fact, some researchers studying brown dwarf systems have proposed that the habitable zone around such a star might be highly dynamic, with periods of intense heat punctuated by cooler intervals.
That's a far cry from the stable, predictable habitable zone that we associate with our sun.
Right. And that difference could have had a significant impact on the evolution of life itself. Imagine life forms adapting to these cycles of intense heat and relative cold. Perhaps develop unique survival strategies, or even thriving in those extreme conditions.
It's like something straight out of a science fiction novel, imagining these alien ecosystems like pulsating to the rhythm of Saturn's flares.
Yeah.
But let's bring this back down to Earth, literally.
Yeah.
What kind of physical evidence might we find here on our planet that could corroborate this theory?
Well, Cardona points to a number of geological anomalies that challenge conventional explanations. For example, he argues that the massive ice sheets that once covered large parts of the Earth might have been the result of a catastrophic event, perhaps triggered by a major flare from proto-Saturn.
Wait, so you're suggesting that ice ages might have been caused by these sudden dramatic events rather than these gradual climatic shifts?
That's one of the possibilities that he explores.
Yep.
He also draws attention to the curious fact that the Earth's axis is tilted, which creates, our seasons.
Right.
Mainstream science attributes this tilt to a random collision with another celestial body early in Earth's history. But Cardona proposes a more intriguing possibility,
right,
that the tilt might be the result of Earth's capture by the sun, this cosmic dance that left our planet permanently off kilter.
Okay, now that's a twist I didn't see coming. So instead of this gentle integration into our current solar system, Earth might have been like violently yanked into its current orbit.
It's a dramatic scenario,
Yeah,
for sure. And
right.
it could explain some of the other oddities that we see in the solar system, like the fact that some planets have orbits that are tilted or even retrograde, meaning they orbit the sun in the opposite direction to most of the other planets.
It's like the solar system is still bearing the scars
Right.
of this ancient cosmic upheaval. But let's get back to the evidence on Earth.
Yeah.
You mentioned ice ages.
Yeah.
What about other geological features?
Well, Cardona points to the massive deposits of sediment and rock formations
Okay.
that suggest catastrophic flooding events on a global scale.
Okay.
And these events, he argues, might be linked to those intense flares from proto-Saturn.
Mm-hmm.
He also draws attention to the fact that many mountain ranges seem to have been formed relatively quickly,
Okay.
as if by some sudden powerful force.
So he's suggesting that the very face of our planet might have been sculpted by these cosmic events.
Exactly, and it's not just the geology.
Yeah.
The fossil record also offers some intriguing clues.
Okay.
For instance, the sudden disappearance of entire species, like the dinosaurs,
Right.
might not be solely attributable to an asteroid impact.
Are you implying that Saturn's flares might have played a role in those mass extinctions?
It's a possibility he explores. He suggests that a powerful enough flare could have disrupted Earth's magnetic field, exposing life to deadly cosmic radiation, triggered massive volcanic eruptions, or even caused a cascade of environmental disasters that led to widespread extinction.
It's a sobering thought, realizing that our planet and all life on it might be at the mercy of these cosmic forces.
It does challenge our sense of security, doesn't it?
Yeah.
But it also highlights the incredible resilience of life, which has managed to not only survive but thrive,
Yeah.
despite these periodic upheavals.
And maybe those upheavals were even essential to the process of evolution itself.
Yeah.
Perhaps those bursts of energy from proto-Saturn acted as a catalyst, driving the development of new species and pushing life towards greater complexity.
That's a fascinating thought. And it ties back to that whole idea of a dynamic, ever-changing cosmos. If the Saturn myth holds any truth, it means that the universe isn't this static, predictable place that
Right.
we often imagine it to be.
Yeah.
It's a place of constant change, of creation and destruction, of cycles of birth, death, and rebirth.
And those cycles might be imprinted not just in the rocks and the fossils, but also in the very fabric of human consciousness, expressed through myths and religions and our deep-seated longing for a lost golden age. This is mind-blowing stuff. It's like we're uncovering this hidden chapter in human history, a chapter that challenges everything we thought we knew about our origins and our connection to the cosmos.
It's a reminder that there's always more to learn, always more to explore, and that the journey of discovery is often more rewarding than the destination itself.
Absolutely. And on that note, we want to thank you, our amazing listeners, for joining us on this incredible deep dive into the Saturn myth. If you enjoyed this mind-bending exploration, don't forget to hit that like button and subscribe to our channel for more deep dives into the world of knowledge. And remember, the universe is full of mysteries.
It certainly is.
And sometimes the most outlandish theories can lead us to the most profound insights.
That's the beauty of exploration.
Keep those minds open and keep exploring. Until next time, keep diving deep.